Again, my name is Mark Lewis. I've been with the department 16 years and with prevention for 5 years. You guys all have access to the PowerPoints. You'll notice there was, as most of the classes you've looked at, both books have overlap. The first book, the smaller book, is really for firefighters to get basic information on systems. The bigger book is for fire inspectors. If you're planning on being a fire inspector, or you are a fire inspector, that's more geared towards you. So what I'm going to do, this is going to be a reasonably short class. I'm not going to go over Chapter 7 PowerPoint because all I'll be doing is reiterating it when I go over Chapter 13. As well, Chapter 13 covers portable fire extinguishers. That's going to be discussed later by James, so we're not going to cover that either. So that's why this class is going to be a little bit short, because we just don't want to do a bunch of overlap. Also, James did cover foam extinguishing systems. We're still going to look at the slides, but it'll just be brief, just so we can say we did those. But otherwise, the class should go reasonably fast. Do you have something, James?
No, just like.
Okay, cool.
Good.
All right, so we'll just get into it. We're going over non-water-based fire extinguishing systems. I will tell you, basically, any of these chapters, the topics you're studying, the whole idea is to look at them from a fire inspector's perspective. So we have a lot of firefighters in here, and you guys are gonna look at the subject matter differently from a different point of view. But I'll kind of here and there maybe point out why we're concerned as fire inspectors on the given topic. So we'll just start out, and you'll have to forgive me, but this is the first time I've taught a class, so if I fumble a little bit, you'll just overlook it. Also, if you guys have any questions as we go, feel free to ask. You don't have to wait, just ask questions. Also, we'll just go over the quizzes at the end of the class. Even though I'm not going to cover Chapter 7, the PowerPoint, we're still going to do the quiz. We'll go over the quiz because you're going to need that information. But like I said, it's just overlapping information, so there's no sense in looking at both PowerPoints. That'll just make your morning longer. So, special agent fire extinguishing systems, why are they used? They're used in locations typically where you don't want to use water. You have either sensitive equipment, or you might have product or that you don't want to damage with water, so you'll use non-water-based systems. That's the gist of it. You guys basically need to know where you're going to use these non-water-based systems. It's pretty straightforward. Flammable combustible liquids, which we try not to put water on unless we're using foam. Water reactive materials, food preparation areas, libraries, places like that. That's where you're going to want to look to find your non-water-based systems. And as fire inspectors, we see the systems. We know they're not water. We don't necessarily have to know the ins and outs of the systems. There are requirements in the fire code for how they're supposed to be maintained and serviced and inspected. There's also NFPA standards that tell you how to do it. And by the way, the difference between, and I'm sure you've heard it before, codes and standards. Codes say you shall do something. Standards just tell you how to do it. It's real simple. So if you get confused between codes and standards, that's all it is. The standards just tells you how to do something that code requires. So NFPA standards tell you how to maintain these systems. You as a fire inspector won't have to know all the ins and outs, but it would behoove you to have some idea of what, for instance, a contractor who's testing and inspecting the system, if you get a report and you've looked at the system yourself and the report comes back clean, and you look at it and go, no, I saw some problems, you're a little ahead of the game. You know some of the requirements for the testing of the system. You can go back and talk to the contractor and say, hey man, did you check this? But as an inspector, you don't have to know how to fully inspect a system. That's not your job. Your inspection of a system is going to happen during the general inspection. You'll look at, damage to equipment. You'll look at whether the gauges are reading correctly. You'll look at whether there's, for instance, on a sprinkler system, if heads are missing. You'll look at a kitchen system and see if you've got a wet system versus a dry system. And I'll explain that in a little bit. But you don't have to know everything as an inspector. You just have to know who to go to give you the evidence that the system is working correctly. All right. So when it comes to these special agent systems, they have to fully extinguish a fire. it's not like a sprinkler system. You cool it down until the fire department shows up to finish the job. These are designed so that in a specific area, once they activate, the fire goes out. I will tell you, in part of the fire code, there's a lot of exceptions. So if you meet certain requirements in the fire code, there's exceptions to having additional safety measures applied to your occupancy. So for instance, if you have a fully sprinklered building, you may not need a special, and you have a certain, I'm going to make it simple. You may have an occupancy where you have a certain operation where the code says, hey, you need to install system B. The exception to installing system B in your building is if you're fully sprinklered, right? So that alleviates a lot of the extra security measures in an occupancy. However, fully sprinklered means fully sprinklered automatic fire system. That means water. So if I have a building where the whole building is sprinklered except for this room because I have special equipment in here, and I install a non-water-based special agent system in here, I now have a suppression here, but my building is not fully sprinkled. So I can't meet the exception, so that extra measure of security is going to need to be installed. It's a little convoluted, but just know that fully sprinklered means you have to have an entirely automatic sprinkler system. All right, we're not going to, so basically, portable fire extinguishers and fixed systems can have the same extinguishing agents in them. There's multiple types, and they're all labeled. This is for most of you, it's going to be boring. You guys probably have you hit this in another class already? Just the classification of fuels. I know the firefighters have their whole career. Just real quick, we'll just go through it. Class A fires, and this is the reason we go over this is because the agent type that you use is based on the type of fire load and fuel load that you have. So Class A fires are just ordinary combustible, so it's paper, wood, rubber. Class B fires are going to be flammable and combustible liquids, gasolines and such. Class C is energized electrical equipment, and as you've read, once you when we show up on scene, our engineers go and shut off electricity to a building as best they can. If we completely shut off the electricity, you no longer have a Class C fire. It's either A, B, or both. And then Class D is flammable metals and the different types of metals. You've read about that. Class K fires would be basically kitchen fires where you've got animal and vegetable fats that burn. So your fryers and even just the grease coming off your hamburgers as you cook them. So you're almost exclusively going to see Class K systems in commercial kitchens. You're not going to see them typically anywhere else. And we don't worry about that note, other than the Europeans seem to do things more sensibly. They just went from D to E, and we jumped to K. But K stands for kitchen, just so you know. It's a Class K. It just so people can remember what a Class K is for. Dry chemical extinguishing systems are used when you need rapid extinguishment and where there's no reignition likely. So the reason they put this up here for dry chemicals is because there's also dry powder systems. So dry powder systems are used exclusively for metals, which if you've ever dealt with flammable metals, they readily reignite. So a dry chemical system doesn't work on those. All right. As far as dry chemical extinguishing systems, you're commonly going to find them in these type of operations: flammable liquid storage rooms, paint spray booths, exhaust ducts. Most likely they're going to be in exhaust ducts. In Tucson, you're rarely going to run into these. Even spray booths are just going to be automatic sprinkler systems. They're just going to be spraying water. So typically you're just not going to see these systems. And you're never going to be an expert on them. You always require, if you have questions about a system, you can require an owner or occupant to have an expert come out and confirm that the system works correctly, and that's by an inspection report. All right, so as far as the inspection duties for dry extinguishing systems, the book does say put a lot of onus on the fire inspector to inspect the systems. Part of your inspection is to look at the system, but what we require when we run into these systems is for the owner or occupant to provide us with an annual inspection report, the most recent one. And at the very least, it should have been within the last year. Sometimes, depending on the system, it may be a 6-month requirement for inspection testing. For kitchen systems, where you see the suppression systems under the hood, over the stove, over the fryer, those may be only 12 months based on the amount of use. So if you have a rec center, Ryan, did you have a question? Okay, so if you have a rec center, for instance, where they do have a hood system and they have an extinguishing system underneath the hood, but they only use the kitchen maybe once or twice a month, maybe every couple months, 12 months is fine for inspection and testing. A kitchen that operates daily, let's say 8 to 9, 8 in the morning, 9 p.m., maybe every 6 months. A 24-hour a day operation, the code may require the inspections to be, NFPA standard may require the inspections to be every 3 months. And then if you go into a restaurant, for instance, that has a wood-fired stove, those are required to be inspected, tested, and cleaned every month. So it's just based on the type of use. So, but as an inspector, you don't have to fully inspect a system and know every in and out of the system. You just need to know the general function of it and when something's not right. And if you're not sure, have them prove it. All right, so as far as the application, you got fixed systems and handheld hose lines. We're not going to, fixed systems are obvious. This is a fixed system, this our automatic sprinkler system. These are what you're typically going to be seeing in any occupancy. The handheld hose lines, maybe in an aircraft hangar you're going to see those, or in a fueling dock. But typically you're not even going to see those. What you're going to see is either fixed systems or portable fire extinguishers. That's what you're going to run into as far as these special agents. Characteristics of fixed extinguishing systems. So components, they're always going to be, for all these systems, for the most part, the components are going to be the same. You're going to have a tank to store the agent. It may or may not be pressurized. If it's not pressurized, there's going to be a separate expellant tank. There's going to be a gauge on it, obviously, to tell you it's under pressure. You're going to get the piping, you're going to get the nozzles, and you have actuation devices. So in most kitchen operations like this, what you're going to find underneath the hood are fusible links. So for those of you that are not familiar with the fusible link, all it is two pieces of metal with a softer metal soldered in between that will melt at a given temperature and then separates the links and it'll activate the system. So in the kitchen system, like I said, it'd be underneath the hood near the front of it where the links are found. So I will tell you, when you're looking at these kitchen systems, they have to be engineered, just like any fixed fire extinguishing system, whether it's water-based, non-water-based, they have to be engineered for the specific application. So in the kitchen, what I mean by applications, you may have a griddle top, you may have fryers. Each one of those components has to have nozzles over them, and they have to have nozzles that give the correct amount of volume when they activate. So they're designed, they're engineered, and then they're installed. So if you're a restaurant owner and you've got your system laid out and you decide, hey, I want to put in new fryers, or I want to add an extra fryer, you actually have to go and pull a permit to change your system because it has to be re-engineered. We have to make sure that you have enough coverage to meet the requirements of the new equipment. Requires trained personnel. So that's discussing the handheld hoses. Again, we don't use them, but if an occupancy does use those handheld devices, the employees have to be trained on how to properly use them. As firefighters, you know, like in high rises, the hose lines have all been pulled if they were ever installed because the hoses aren't maintained typically by the occupancy. People aren't really trained in how to use them. Firefighter, we're not going to use them because we don't trust them. So without the proper training, these aren't acceptable anyway. All right. Name types of dry chemical application methods. We don't have to worry about that. And by the way, again, there are going to be some things in the PowerPoint. It's good to know, but they don't have to be memorized because an inspector, you're not going to memorize. You're going to learn as you go, and your references are going to be your code book and your NFPA standards. So the characteristics of dry chemical agents, they're used again where water is going to be ineffective or it may cause damage to your components and systems. The special agents separate oxygen from fuel and they'll inhibit the chemical chain reaction or they'll cool. They operate just like water except they don't do the damage of water. Not recommended for areas that contain, so when it comes to dry chemicals, the reason you don't want to use them for sensitive electronic equipment, as you've read, the powder disperses, it gets everywhere. It gets on exposed wiring components. It can be corrosive if there's water or moisture in the air, and it involves a substantial amount of cleanup. So it's not always the best option. That's where you get into some of your clean agent options or water-based systems that can more specifically direct a stream onto the fire. Corrosive, moisture, we discussed that, chemical residue on contact points. Different kinds of dry chemical agents, I would say just be familiar with the types. The only reason you'd want to even know what's in a system is, as an inspector, is if there's a known hazard. So before you go out and do an inspection, you'd want to do some research on your occupancy. You want to find out what the production type is, how many people are in the building, what the process is, and the end result of those processes are. So if I have an extinguishing system, for instance, I just want to know if there's a hazard. If there's a hazard, I want to be able to do research to see if we need any kind of signage warning, any special training for the employees. You want to know that going in so you can ask the owner or occupant if they're meeting those standards. So that's all part of the inspection. So memorizing this isn't so important. It's just understanding that there is an agent. Are there any hazards? If there's no hazards, there's really not a lot you need to worry about. Sodium bicarbonate, there's not a lot of hazards regarding that. There's potassium bicarbonate. So basically, these slides are telling you one's more effective on B and C fires, not necessarily Class A fires. But you can use them all on Class A fires. They're just not necessarily going to be quite as effective. This is probably the most effective of the three agents, the monoammonium phosphate. Again, you don't have to memorize all that. Just know that these are extinguishing agents. As far as components of systems go, all this is showing you is that there's storage tanks and expellent tanks. Typically, you're not going to see a setup quite as elaborate as that. That would be a pretty large facility. Usually when you see storage tanks or cylinders, there's just going to be one. There may be one storage and one expellent. And for the most part, you're going to see these in kitchen systems. And they have to be protected from excessive heat. So they're usually inside the building. They're fairly close to the hood system. So wherever these are installed, they have to be close to the components that they're inspecting, because you don't want large pipe runs. And again, these will be engineered, so you don't have to worry about whether or not the system is, if it has a permit, you can do that research. You don't have to worry so much that whether it was engineered properly or not. Storage containers for agents and expellent gases, pressures, don't necessarily need to know that. You just need to know that they are under pressure. So if there's an issue, you just need to know you've got a pressure cylinder. Again, you do have to maintain the temperature in the area, so you don't want to expose these to climate damage. Piping to carry the agent, just engineered for the specific agent that's being flowed through it. So when they engineer it, they look at the length of the runs, how many bends. There's only a limited amount of bends that you can put in, just like any system. The nozzles have to meet the agent type. It has to be, the nozzles are specific to the agent being used, and also the amount of flow that's required to put out the fire on the product that's burning. So they have to look at all those factors when they design the systems. Again, no standard nozzles. So when they're talking about no standard nozzles exist, what they're saying is you may have a particular agent. Nozzles by different manufacturers are going to vary. So you have to make sure as an inspector that they're following the manufacturer's recommendations as far as installation of their particular product. Activation systems, fusible inks. So in any special agent extinguishing system, there are going to be actuation devices, whether they're mechanical or electrical. Typically, you're going to see fusible inks, but you can still get smoke and fire detectors that activate systems. There's also manual pull stations on a lot of them, especially in kitchens, and we'll touch on that in a little bit. All right, the actuation mechanisms, we already talked about that. So not every system, for instance, kitchen systems, they, other than being connected to the fire alarm system, they're not going to have special strobes or indicating devices. But when it comes to your clean agents, CO2, the dry chemical systems, they do require that there's audible signals that let employees know that there's been an activation. And they have to be trained on what to do in case there is an activation. Usually they're in specific areas of a building. So with a sprinkler system throughout typically, but you're not going to find dry chemical, wet chemical. You're not going to find CO2 systems throughout a building. They're in a specific area of an occupancy. So the employees have to be trained on what to do if there is an activation. And we'll touch on that a little bit as well. All right. As far as fire protection companies, detailed maintenance of the systems, we talked about it. Ultimately, the owner or occupant of the building is responsible for maintaining the systems and making sure they're inspected. So they have a service provider come in and do the work. We're not going to come in every year and verify that these systems are being maintained because we don't have enough inspectors to hit every business. We can't even come close. So ultimately, it's their responsibility. If we do get to them and do an inspection, we're going to want to see documentation that they are maintaining their systems. They're required to have their documentation on site for 3 years. So at the very least, 3 years worth of reports. I just did an inspection on a facility where I had a complaint where the sprinkler system hadn't been looked at in over 10 years. I had a pretty good indication because the inspector test valve on the outside was just full of pigeon dung, and years of it. It was probably 4 or 5 inches thick. So I have a pretty good idea that the system hadn't been inspected. So ultimately, it's the owner's responsibility to make sure the systems are maintained. All right, dry powders are designed to extinguish Class D fires. We touched on that a little bit. You're not going to use dry chem on burning metals because they're not going to stop a reignition of the metals as they burn. Most of the agents that they use to extinguish burning metals will melt and form a film over the metal. So they'll not only cool it off, but they'll separate the metals from the oxygen, unless the metal gives off oxygen as it burns. They did talk about graphite as an extinguishing agent. That's the one agent that does not melt. It just forms a layer over the burning metal. So again, they can reignite. So, and aside from this, Class K fires, kitchen fires where you have especially deep fat fryers. I was on a fire at a Burger King, and the fryer was on fire, and a firefighter took just a multi-chem extinguisher, and he thought, well, we'll save some water, we'll just get this knocked down real quick, and he used the extinguisher on the fryer, and it worked. It put out the fire, it put a nice thick layer on top of the oil, and probably about 2 minutes later it reignited, because it's the new cooking oils, the vegetable-based cooking oils burn so much hotter now that you're not able to stop the reignition of the oil. So that's why we have the Class K extinguishing systems, because that creates, and a lot of you know the term saponification. When that Class K agent hits the oil, it mixes and creates a foamy, soapy layer that keeps oxygen from, it just separates the fuel from the oxygen and cools it off enough that it'll stay extinguished. All right, so they talk about Class D agents. It's fine to go through and look at the characteristics of these agents, but just know that you have different types, and if you run into these systems, you just need to be able to do the research to find out if there's any hazards pertaining to these. So as you're looking at these, this is a carbonate-based agent. It's specifically for sodium and potassium. They say it's not suitable for magnesium fires. So they are specific to the type of metal that's burning. Some will, obviously, all of them work on multiple burning metals, but they don't work on all burning metals. But that's not your job to know that it's obviously the occupancy. There's a liability for the owner or occupant of the building if they don't use the right extinguishing agent. And it's not going to be, when the permits are pulled to install the systems, they won't be allowed to be installed unless they meet the requirements for the product that they're being installed for. It just tells you forms an encrusting or cake over the burning material applied from thick systems or hand pails listed by UL. It is important that it's a listed product. You just need to know what the hazards are for this product. You don't even necessarily need to know if that's the right product for the system, because like I said, you're not going to memorize all this information. You can do the research after the fact and determine, hey, this is the metal product that you've got in your business, and you're using an NAX on it. That's not appropriate. But that requires research after the fact. Going in, you don't have to necessarily know that. All right, this Met LX, again, sodium chloride, has additives to prevent caking. It extinguishes metal fires by forming a crust. All these basically do the same thing. They're just made by different manufacturers. The components that make up the product are a little different, but they all do the same thing. This is the graphite-based one. This is the only one that doesn't form a crust and melt. All right, so again, talking about the characteristics of wet chemical systems, they're most effective on commercial cooking equipment, and that's pretty much the only place you're going to see wet chemical systems is in kitchens. You're not going to see them many other places. But I can again, I'll just reiterate, you're almost always going to see automatic sprinkler systems, so water. Even in systems where you would think they would want to protect their property, they're still going to use water because it's cheaper to install and it's cheaper to maintain. These react with the animal and vegetable oils and form soapy film over the top. Again, we talked about that. So it talks about the difference between dry and wet chemicals. So when you have dry chemical systems versus wet chemical systems, they're basically designed, engineered, and plumbed the same. It's just what comes out is different. So in a lot of kitchens, prior to I'd say 4 or 5 years ago, most of the kitchen systems had dry chemicals in them. A new standard came out from NFPA, it was a UL standard, UL 300 systems, and NFPA requires that now all kitchen systems meet the UL 300 standard, and that's a wet chemical system. The dry chems just weren't putting out the grease fires with the hotter temperatures, so they went to the wet chemical systems, which is a Class K. Just so you know, if you see a kitchen system, you can have a combination of a dry and wet chemical system, but they have to activate simultaneously. You're really never going to see that. What you're going to see is a wet system throughout, even though it's only required for the deep fat fryers typically. The whole system is going to be a wet chemical system. Again, they're plumbed the same, they look the same, the product is different. So if you do have an activation of a system and you see powder all over it, odds are they don't meet the standard. And as firefighters, if it crosses your mind, you can call fire prevention. We'll go out and require them to install a UL 300 standard system. Other than that, that's pretty straightforward. All right. Typically, wet chemical systems are composed of water, potassium carbonate. Again, you don't need to know the componentry. You just know it's wet. It's the right system for the job at hand, and they deliver a foam. I will say the benefits to an operator of a restaurant, as far as an activation of a system. If you have a dry chem system, everything in the kitchen that's open has to be replaced. Wet chems, they don't disperse throughout the room. They're pretty directed, so they'll hit the components that they're required to cover. So just food in the immediate area that's open will have to be disposed of, but the rest of the kitchen is good to go, and they don't have to replace the product. So with an activation, it's cheaper for them to have that system. All right. So clean agents, effective on Class A, B, and C fires. They don't conduct electricity, and the biggest part is they don't have a hazardous health component to them. And they're approved by the EPA. They don't destroy the ozone layer. So that's a big plus for these systems. And as we'll talk briefly on it, a lot of these are replacing halon systems. They're stored as liquefied compressed gas, so when they do activate, they become a gas and they expand, and so they basically disperse the oxygen in the room and they completely suffocate a fire. The important thing to know about that is These systems are typically used in small rooms where you're protecting special componentry. They're not going to work if you have gaps in the door, if you have piping and electrical conduit coming through the wall, and the holes around the piping and conduit aren't sealed. You're not going to get a good seal in the room. So as these extinguishing systems expel the gas, they escape the room. They're not going to effectively put out the fire. So these rooms have to be able to seal. So when they're activated, ventilation systems shut off, and they're able to smother the fire. The idea is they completely extinguish the fire. There should be no fire after they operate. So they're not appropriate for occupied areas, mainly because some of these may actually displace oxygen, and that's about it on that. All right, so again, where they're used: computer rooms, telecommunication facilities, document archives, laboratories, and where you have sensitive equipment that's can be affected by corrosion. I will see them often in computer rooms and telecommunication facilities and rooms, but most of these other areas, it's cheaper just to install water systems, and so you're still going to see, again, automatic sprinkler systems even in archive rooms and in libraries. All right. Sorry, I have to look at this real quick. And so again, the first group of clean agents developed are principally designed for Class B and C fires. There were halons, again, detrimental to the atmosphere, and halons are now being discontinued. They don't manufacture them anymore, but they're still in use. So we run into halon systems. If they're still functional, if they've been inspected and tested, and they haven't been activated, we don't require them to be replaced. It's really expensive proposition to replace these systems. If for whatever reason the system's activated and or needs inspection and has to be refilled, again, we're not necessarily going to, even under those circumstances, ask them to replace the system, because there are still halon available to purchase that's already been produced. And until that gets used up, there's lobbyists in the world that say, hey, this is going to cost our industry a lot of money. So we can't just completely discontinue use. We have to be able to use up our stock. So we allow those systems to still be in operation as long as they're maintained. However, there are, again, and these are the two systems that are still commonly found. It's the Halon 1211 and the Halon 1301. These things are not, you're not going to, again, as an inspector, you're not going to memorize all this stuff. You just know the Halon systems are out there and that they can have health effects and they do destroy the ozone. They're not EPA approved for release to the atmosphere. They can be recycled. I don't know what the recycling process is about, so I can read this to you like a monkey, and it won't mean anything to you guys either. All right, these are the clean agents that are commercially available. These are just the different types of agents. The systems are designed for that specific agent. I will say, if you have a halon system as an owner and you want to replace that halon system, you don't have to replace all the piping. The only thing that you have to replace is the container holding the new agent that's replacing the halon, and you have to replace the nozzles because the nozzles are specific to the product that's being applied. So again, you've got halocarbon agents, not harmful to the environment, meet EPA standards, and doesn't really, most of these are about as effective as the other. It's really dependent upon cost, really, as to what kind of agents you're going to have in your system based on the occupancy. The Energen is just natural gases, a Caro 25, again, zero ozone depletion, environmentally preferred over halon, again, for the reason that halon destroys the ozone layer. Another alternative. All right. Fixed systems are designed for local application or total flooding. So all that's really stating is either you're going to totally flood the room or you're going to have directed nozzles. So usually where you're going to have directed nozzles is if you're in a larger open space, or you have a system that's designed outside. a flooding system isn't going to do you any good, because that's for compartmentalized areas where you can actually create a suffocation effect. These locally applied just have, they blow the agent directly onto the fire, and usually they want to have a low pressure nozzles so they don't blow the fire and destroy other systems or components. Again, they have activation devices, storage containers, piping, discharge nozzles. See, the systems are pretty much all designed the same. You're going to have the storage, piping, nozzles. All right. Clean agents are proven effective. Again, this is just a checklist for fires involving many types of combustible materials. Less effective for fires involving nitrates. What that's talking about is nitrates give off oxygen. They have available oxygen, so some of these agents don't work as well on them. Oh, sorry, that's a carbon dioxide system. So the problem with the carbon dioxide system, and the reason it's a clean agent, but it doesn't have the same characteristics of the other clean agents, as this can be hazardous, obviously, to occupants and to firefighters, because it does displace oxygen. So the biggest takeaway here, CO2 displaces oxygen. You walk into a room that's chock full of the CO2, and you're gonna drop and probably not gonna make it to your next day. CO2 extinguishes flammable combustible liquids, works on energized equipment, flammable gases, and then other materials like cellulose materials, so a movie film. It's cold, so the biggest takeaway here, and really you're looking at handheld systems, is CO2 can cause damage to skin, so you don't want to apply it anywhere where there are personnel that are going to be affected. It doesn't really cool the fire so much as it smothers the fire. All right. So these are the places where you may find CO2 systems: automotive manufacturing facilities, industrial plants, paint coating operations, power plants. Again, most of these places that I've been to, water-based systems. Even where you might expect that it would make sense for CO2, you don't see it that often. All right, handheld hose lines and standpipes are also used. Again, you're not going to see these very often. All right, the hazards and the effects of CO2, it's an asphyxiant, it eliminates oxygen from the room. Total flooding systems are of specific concern. So we don't need to necessarily go through these. The concentrations are lethally human at 34%. They totally flood an affected room. When we go in as inspectors, we just want to make sure the room is sealed, so this works effectively. It's not a good system if it doesn't seal the room. It's directly applied to the fire as opposed to filling an enclosure for the flooding systems. Local application. The only thing that this is stating as far as reduced hazard to personnel is local application. Again, it's typically in open areas or outside. So CO2 doesn't have an ability to concentrate and cause a hazard. Again, the systems are designed similarly. I'm not going to bore you with this. It's all the same components. You have to have an activation system. The thing with the CO2 systems, though, and what this is telling you is CO2 systems have to be designed so that if there's a fire and the system's going to activate, you need to have an audible alarm prior to the activation of the system and enough time for employees to get personnel to get out of the room or the building. Typically, the limited area where the activation is going to occur, employees have to be trained on the system as well, or at least understand how the systems work and know how to get out, when to get out. So if the system doesn't automatically activate, there would be a manual operation like this pull station. The way this first pull station is designed is if the system doesn't automatically activate, when I pull that, the system again doesn't automatically activate. It's going to have a delay. It's going to set off an alarm. So it's going to give the person who pulled that handle time to get out before the actual activation. And then there will also be an alarm once the system discharges. the emergency, the last option, which is emergency manual operation, it's only used when the other modes fail. So typically, this is particularly where employees have to be trained on the system. Based on where that operation occurs, the employees may have to be trained on how to use respirators, right, with supplied oxygen, or in order to give them time to get out prior, because this is going to activate right away. There's not going to be a pre-activation alarm. CO2 systems can be high or low pressure. You're going to see cylinders, and you're going to see tanks. So the cylinders are the smaller containers, and you've got larger tanks. These are higher pressure, lower pressure. They both can use high or low volume nozzles. Typically, I've never seen one of these. As a matter of fact, I've never even seen the CO2 high pressure systems in use. The only time typically you're going to see CO2 out in the field, and you guys see it when you go into restaurants, is those big CO2 doors that are used for they're used for serving the beverages through their beverage dispensers. You'll also see CO2 doors at pools because they do use it to help maintain the pH levels of the water. So, and they can be those large doors as well, and those are really hazardous. All right, in either high or low pressure system, the containers are connected to the discharge nozzles through fixed piping. So it's going to be the same thing with all your other systems. You're going to have your containers that discharge the product. You're going to have the piping, nozzles, and actuation devices. So, and then you guys probably covered this to the point of tedium. We're not going to go over this too much, but foam extinguishing systems you are going to find out in the world. You're just not going to find very many of them. Typically, really the only place you're going to see these is in aircraft hangars. They talk about flammable liquid processing in storage facilities, rolled paper, fabric storage facilities. I've gone into, the Arizona Daily Star, and they're just using automatic sprinkler systems. They're not using foam. The advantages to the foam systems is they smother the fire and prevent air and flammable vapors from combining. They intervene between the fuel and the fire, cool off, prevent the release of flammable vapors. Most of this you guys are all familiar with. Foam suppressed fires by forming a chemical layer. These are all things that you would have covered, correct, James, in your class?
Yeah, I think so.
Okay.
Hands up if you don't know what he's talking about.
All right.
If you don't,
So,
get out.
Did you talk about the proportioning in your class?
Yeah, we proportioned to death.
Okay.
So
Do you guys want to be proportioned to death?
even
Probably
showed him
not.
that exact picture.
So I will tell you, so you look at these systems, again, so this might throw you off because you're gonna see this big foam tank, and you might not readily identify this as a foam system. This is where you do your research before going in, and this is where you have conversations with the building occupant. What kind of system do you have? If it's a foam system, it's pretty straightforward. There's not a lot that you need to know about a foam system. It dispenses water with concentrated foam. So again, this is just how they're applied to foam concentrates. We're not going to discuss this because you guys covered this ad nauseum. Basically, remember when I told you this was going to be a short class? I didn't lie to you. Holy cow! So, I guess the biggest takeaway on these is, for these foam systems to work, you need water mixed with the foam. They go through a proportioner. They hit the nozzle. They're aerated. If they're proportioned correctly, foam's going to come out. If they're not, you get no foam. And that's not your responsibility as an inspector. It's a responsibility of the building occupant to make sure they operate correctly, and they have to get tested just like every other system. All right. So basically, where we're at here is going to fire extinguishers. These are portable fire extinguishers, and we're not going to talk about that because James is going to cover that. So that's it for the class. I told you it would be short. Forgive me for not being an educator. I did my best. We're going to go over the quizzes right now, just to make sure you have all the answers to the quizzes. So, and we can just go around the class and just answer the questions. There's no pressure here. If you get them right, we can talk about it for a second. So we're going to go over quiz 7 first. And I guess do you mind starting, Ryan, with number 1?
Suppression systems are classified based upon the classifier or
Correct.
How are special suppression systems generally designed with with a specific hazard or application in mind?
Correct.
Mark, can you just, for the camera, for the purposes, in case someone's coming to get these answers at home,
Pardon me?
for the camera, can you just make sure you repeat the number
Okay,
and the
we can
correct
do.
answer or the
Okay.
correct letter,
You
just so
bet.
that they have it for home purposes?
So for number 1, special suppression systems are classified based on the D classifiers that they can be effectively distinguished. And number 2, how are special suppression systems generally designed? The answer is B, with a specified hazard or application in mind.
Which type of fire suppression system is most effective when used on fires and DFAT fires? C, wet.
So for number 3, which type of suppression system is most effective when used on fires and deep fires? The answer is C, wet chemical.
Wet chemical system components typically are stored on a storage tank or tanks, piping nozzles, and a de-actuated.
Number 4, wet chemical system components typically are a storage tank or tanks, piping nozzles, and an actuating mechanism, D. So number 5, dry chemical suppression systems are most commonly used to protect C, exhaust duct systems, correct?
Too many types of fixed dry chemical systems on local application and the total flooding.
Correct. Number 6, 2 main types of fixed dry chemical systems are local application and D, total flooding.
Which type of fire suppression system uses special extinguishing agents that leave little or no residue? A, clean agent system.
Correct. Number 7, which type of fire suppression system uses special extinguishing agents that leave little or no residue? The answer is A, clean agent systems.
Clean agents extinguish fire by smothering the burning material, excluding oxygen, and D, interrupting the chemical chain reaction.
Correct. Number 8, clean agents extinguish fire by smothering the burning material and excluding oxygen, and D, interrupting the chemical chain reaction of the fire.
Carbon dioxide systems have proven effective for extinguishing most combustible material fires, with the exception of subreactive metals, metal hydrides, and other materials that contain available oxygen.
Correct. Number 9, carbon dioxide systems have proven effective for extinguishing most combustible material fires, with the exception of some reactive metals, metal hydrides, and other materials that B, contain available oxygen.
The most serious problem involving carbon dioxide systems, especially total flooding systems, is A, personnel safety.
Correct. Number 10, the most serious problem involving carbon dioxide systems, especially totaling flooding systems, is A, personnel safety. All right, now, Chapter 13 quiz. Who do we leave off with? You want to go, Anthony?
Sure. Number 1, special agent fire extinguishing systems are classified by the B type of fire they'll extinguish.
Correct. Number 1, special agent fire extinguishing systems are classified by B, the type of fire they will extinguish.
What type of special agent fire extinguishing system is used when rapid fire extinguishment is required in our ignition, unlike C, direct system?
Correct. Number 2, what type of special agent fire extinguishing system is used when rapid fire extinguishment is required and where reignition is unlikely? The answer is C, dry chemical systems. You want to start again, Ryan? Yeah, please.
Which special agent fire extinguishing system is effective when fires and extinguishing
Correct. Number 4, which special agent fire extinguishing system is most effective on fires in commercial cooking equipment that produces grease-laden vapors? The answer is D, wet chemical systems.
What general category of fire extinguishing agents effectively leaves no residue? Clean agents.
Correct. Number 5, what general category of fire extinguishing agents effectively leaves no residue? B, clean agent systems.
Which special agent fire extinguishing system is extremely cold and can freeze exposed skin? D, carbon dioxide systems.
Correct. Number 6, which special agent fire extinguishing system is extremely cold and can freeze exposed skin? Is D, carbon dioxide systems.
Which system is used when water alone may not be an effective fire extinguishing agent? A, foam system.
Correct. Number 7, which system is used when water alone may not be an effective fire extinguishing agent? A, foam system.
Number 8, the value of a fire extinguisher lies in D, the speed at which it can be used.
Correct. Again, these are, the only reason I didn't mention not to do the fire extinguishing questions is because you're going to need to know them anyway, and since they're on this quiz, we'll just continue with that. So number 8, the value of a fire extinguisher lies in D, the speed of which it can be used.
Portable fire extinguishers are classified by the type of fire they will extinguish.
Correct. Number 9, portable fire extinguishers are classified by the A, type of fire they will extinguish.
Number 10, how are portable fire extinguishers rated? D, type of agent used and location, and occupancy.
So how are portable fire extinguishers rated? The answer is C, intended use and the extinguishing capacity. So on that one, and again, you're going to cover this anyway, so it's no big deal. But the fire extinguishers are rated just like fixed extinguishing systems based on the type of fire they're going to extinguish, class A, B, C, D, or K. And then as far as the extinguishing capability, it's the volume of the extinguisher and how much square footage it's expected to actually be able to effectively work on.
That's pretty much my entire class right there, so, great.
All right, and then number 11.
Which aspect of fire protection with portable fire extinguishers is essential but often overlooked? D, extinguisher placement.
That's correct. Number 11, which aspect of fire protection with portable fire extinguishers is essential but often overlooked? And it is the extinguisher placement. And I won't talk about that. I will let James have his
Leave me
day
something
in the
to do.
sun. But, and so that's it. I appreciate your patience with me, and I'm happy to give you a short class today.